Hello. In this video, I'm going to talk about how to formulate a linear programming model for a post office scheduling problem. The description of this problem is as follows in this screenshot here to the left. You're in charge of operating a post office and need to determine how to schedule personnel in order to adequately staff the post office at minimum cost. The agreement with the union requires each employee to work 5 consecutive days and then be granted 2 days off. The staffing requirements for each day of the week are as follows. So we have this table of Sunday through Saturday, and these values represent the staffing requirement. It continues and it says employees are paid based on the days they work, and each day has a different salary structure. In particular, the daily salary costs for each day of the week are as follows. So if a person works Sunday, they make $30. If they work Sunday and Monday, they make $50, so on and so forth there. We have this caveat that says, in addition, any employee working both Saturday and Sunday must be paid an extra $20. So let's say you work Saturday and Sunday, you would make the 30 plus 30, $60, but because you worked both of those days, you would make $80 total dollars. And so what we're going to do is we're going to take this description and formulate it as a linear programming model. And so first, the thought might be, hey, this looks like an integer program where we would have discrete number of people. But we're going to do it as a linear programming model because you can always send people home early, or they don't necessarily have to work that full day there. So the first thing that we need for this is we need a set of decision variables. So here on the right, I am going to write down our model. So here we have decision variables. The most common thing that people want to do for this model is to say, let's say x1 is the number of people working on Sunday. And then you would continue on all the way to x7. That would be the same, but for Saturday. And so what happens when I'm going to let you play with this there, but I'm going to skip ahead. But what happens here is when you have this x1 as the number of people working on Sunday, you lose the ability to have this agreement with the union that you have to work 5 consecutive days on and be granted 2 days off. So if you had 10 people, let's say, working on Sunday, there's no continuity of, did 10 people work on that previous Saturday? Do those 10 people have to continue on Monday to work those 5 days on and 2 days off? So while this is the first natural thing to do, it is not the way to go about modeling these decision variables. Instead, we want to impose more structure of this 5 days on and 2 days off into our set of decision variables. So instead now, I'm going to define a set of decision variables here as xj and say that it represents the number of people working shift J. And so what's happening here is I am now going to create a set of shifts, and I'm going to say I'm going to create n shifts here. Based off of which 5 days you're working and which 5 days you're off. So for example, I could say x1 here as the number of people working shift 1, whereas I'm going to say that that is Sunday, Monday, Tuesday, Wednesday, and Thursday. So there's your 5 days. I'm going to say that x2 is the number of people working shift 2, whereas now instead of starting on Sunday, I'm going to say that they start on Monday and they work until Friday. I'm going to continue on with this general idea as x3 the number of people working shift 3, which is going to be Tuesday, Wednesday, Thursday, Friday, Saturday to Saturday. And then 4, 5, 6, 7. You can think this is the same across. The shift number changes and the days change. So we have the people that start on Sunday, Monday, Tuesday. We're now going to increment Wednesday. So Wednesday, Thursday, Friday, Saturday, Sunday. You start Thursday, Friday, Saturday, Sunday, Monday. You start Friday and you work Friday, Saturday, Sunday, Monday, Tuesday. And then you work Saturday, where you work Saturday, Sunday, Monday, Tuesday, Wednesday. And so what this design does is we allow to incorporate this 5 days on and 2 days off and don't have to worry about tracking that with our constraints. And so this would be our set of decision variables that we need for this model. The next thing we need to do is we need to have a set of parameters and sets. And so thinking ahead of data that we've been given. So we've been given about our staffing requirement. We've been given information about our daily salary costs as well as this extra $20. And then also we can think about sets that we would need to create. So we have these sets of shifts, but we also might want to be creative in how we're defining our sets. So if we think ahead to what we need to limit or have as an objective, we reread this and say we want to staff the post office at minimum cost. So we need some cost for staffing the post office, and so that should probably be a parameter. And so what I'm going to do is, instead of taking these as individual costs, I'm going to aggregate them into costs per person working each shift. So for example, shift 1 works Sunday, Monday, Tuesday, Wednesday, Thursday. So if I add the costs for Sunday, Monday, Tuesday, Wednesday, and Thursday, I get $115. So I know the cost of people working that shift is going to be 115 times those number of people working. So this is going to be our first parameter here. And so I'm going to define it as CJ as represents the cost per person working shift J. And we don't have just one number for this, but we have what would be N numbers. And so I'm actually going to back up and say N is our number of shifts. And so for this problem, we have 7 shifts, one that starts each day of the week. If we had different combinations where you have some days on and some days off, that number would change, but for right now we have 7 shifts, which means we're going to have 7 different cost values. So I already said that shift 1 that works Sunday through Thursday, I would add up these numbers and I would get 115. So I'm going to say here C1 is 115 because that's the cost of shift 1. We can do this for all of these, and we have C2 is 110, C3 is 120. So some things we need to be careful about is this extra $20. So shift 1, you're working Sunday, Monday, Tuesday, Wednesday, Thursday. You don't work both Saturday and Sunday. Shift 2 is Monday through Friday. They don't work either Saturday or Sunday. Shift 3, Tuesday to Saturday. Again, you are just working one of those, but when we think about shift 4 starting on Wednesday, you are working both Saturday and Sunday. So our cost for people working the shift is the 20 plus 25, 25, 30, and 30 plus an additional 20, which gives us a cost here of C4 is equal to 150. And you can double check the math here. I'm just going to give you numbers. When we think about shift 5, you're working Thursday, Friday, Saturday, Sunday, Monday. And so you are incurring this extra $20. So I'm going to say C5 here is also 150. And then you would continue on. Here C6 is 145 and C7 is 140. So what we've done is we've taken this data about cost and incorporated it into a way that can be helpful when we get to our model. So the next thing we need to think about is that what we're going to have constraints for. And so we have this information about a staffing requirement, and when you read this, you say for each day of the week. And so this is something we need to ensure for each day of the week. So when you see that, you should be thinking, this is a constraint, and I should be having 7 constraints, 1 for each day of the week. So in order to make this a little easier when we're representing this, I'm going to create a set here called days. And I'm going to say that days represents the days of a week. And so here I'm going to say days equals, you can say Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So we could use 1 through 7, but just to further distinguish that a day is different, day 1 is different from shift 1, I'm going to represent it as its 3-letter abbreviation for that particular day. Okay, it's just being a little slow to go up there. Okay, there we go. And so once we have this days, we know that we have a certain staffing requirement for each day. And so I'm going to represent that as RI here. And I'm going to say RI represents the staffing requirement for day I. So just to be clear here, I'm using I for a day of the week, and I'm using J for a shift. Okay, and so here for day I, for I in days. So we have our Sunday, which if we look here, our Sunday is 10. We have our Monday, which is 20. Our Tuesday is also 20. Our Wednesday is 25. Our Thursday is 15. Our Friday is 15. And our Saturday is 15. Okay? And so with that, we've now incorporated this staffing requirement. The last thing that we need to do is to determine what shifts are working on each day. So for example, if I am working shift 1, I'm working Sunday, Monday, Tuesday, Wednesday, Thursday. So if one person is working that shift, then that should count towards the staffing requirement for all of those days. And so we need to know, okay, we know shift 1 works on Sunday. Does shift 2 work on Sunday? No, it doesn't, because shift 2 works Monday through Friday. Does shift 3 no, shift 3 works Tuesday through Saturday, but 4, 5, 6, and 7, those shifts all work on Sunday. And so here I'm going to create another set for each day of the week to represent what shifts work on that day. So here I'm going to say DI represents the shifts working on day I. Again, I'm keeping I as day, J as a shift. And so we're going to create one of these for each day of the week. So for each I in days. So here we know I takes on the values of days. So let's do D of Sunday. Okay, so D of Sunday, we're creating a set. And so we can think here, shift 1 is Sunday through Thursday. So shift 1 does work on Sunday. We already said that shifts 2 and 3 do not work Sunday because shift 2 is Monday through Friday. Shift 3 is Tuesday through Saturday. They do not work Sunday. So 1 is, 2 and 3 are no. Shift 4 is Wednesday, Thursday, Friday, Saturday, Sunday. Yes, shift 4 does work on Sunday. Shift 5 starts on Thursday, Friday, Saturday, Sunday, Monday. 5 does work on Sunday. And the same would be true of 6 and 7. I'm then going to determine what shifts work on Monday. So we can think, does shift 1 work on Monday? Okay, shift 1 starts on Sunday and goes Sunday, Monday, Tuesday, Wednesday, Thursday. So shift 1 does work on Monday. And you can continue the same logic where you say, does this shift work on this day? And fill out our set of D sub I sets. So I'm going to continue and just fill in these values based off of my pre-calculated work. But you can feel free to stop and fill this in yourself and verify that your logic matches with my logic. So last one here, 3, 4, 5, 6, and 7. And so each of these sets, just to go over some set notation, you'll see these curly brackets to denote a set. And so each of these sets has 5 elements. So this is saying that 1 is an element of this set, but 1 is not an element of the D Friday and D Saturday sets there. Okay, so now we have all of our parameters and we can move on to modeling. And so what we want to do, I'm first going to model it in the first format here. So what I'm going to call model format 1. Okay, in model format 1, I'm going to write out all of the constraints, all of the objective function. And model format 2, I'm going to use summation notation. So when we go back to this problem, we have to identify what's our objective function. So we can skim through this, and some things that I see to point out first here is this: that we want to staff at minimum cost. So our objective function is either minimum or maximum. So whenever you see minimum or maximum in the problem, you should be thinking objective function. So this here is exactly our objective function. And so we have a minimization objective function, which you can abbreviate as min. Then we have to calculate what's the cost to staff our post office. Well, we already calculated these costs here, which is the cost per person working that shift. We also have a decision variable for the number of people working that shift. And so if we multiplied CJ by XJ here, so CJ by XJ, we can get the cost for all people working that shift. So if I go down here and I say, 115 times x1, that's the cost for all people working shift 1. We can continue on and say plus 110 x2 plus 120 x3 plus 150 x4 plus 150 x5 plus 145 x6 and plus 140 x7, and we have our objective function. I'm going to add an equation number just so I can reference it later, and so I'm going to keep the numbers the same between my two model formats, and I'm going to index all of my model format 1 using an A. Now we have our set of constraints, which you would say subject to, which can be abbreviated as S dot T here. And so if I read through this description again, we say, okay, this next sentence here sounds like a constraint, 5 days on and 2 days off. And we have to ask ourselves, do we need to incorporate this? We don't, because it's already incorporated in the decision variables. Then we have the staffing requirement for each day of the week. And so this is a constraint where we need to meet the staffing requirement for Sunday. We need to meet the staffing requirement for Monday, so on and so forth. So let's take our Sunday staffing requirement. So what we want to do is say everybody that's working Sunday, the total of that has to be greater than or equal to 10. Well, we've already done some work and said shifts 1, 4, 5, 6, and 7 work on Sunday. So we can write this here as x1 plus x4 plus x5 plus x6 plus x7 has to be greater than or equal to 10. This is our Sunday constraint. I'm going to label it as 2A. We have another one for Monday, and we can say here the people working Monday has to be greater than or equal to 20. So here we go x1 plus x2 plus 5, x6, and x7. And that has to be greater or equal to Monday's staffing requirement, which is 20. And I'm going to label that 3A. I'm going to continue this on and have a constraint for each day of the week and say that the amount of people, the total of those people working has to be greater than or equal to the staffing requirement. One common mistake that people make is they'll try to incorporate this extra $20 into a constraint. The $20 has nothing to do with the number of people have to be greater than or equal to the staffing requirement. That $20 is incorporated into our objective function, adding it to those costs for shifts that work Saturday and Sunday. So here we have, going back to the staffing constraints, we have a Sunday staffing constraint, we have a Monday, and we're going to continue on for Tuesday, Wednesday, Thursday, Friday, and Saturday here. So I'm going to go on here and say for Tuesday, I know that shifts 1, 2, 3, 6, and 7 all work on Tuesday, and those have to be greater than or equal to 20, which is the staffing requirement for Tuesday. For Wednesday, you can verify, but Wednesday we have shifts 1, 2, 3, 4. I'm off a little bit in the columns here. And 7 has to be greater or equal to the staffing requirement for Wednesday here. So I'm going to label that 5A. And then I'm going to continue on for Thursday, Friday, Saturday. The same logic applies, so I'm just going to go through this quickly. So we have 1, 2, 3, 4, and 5. Those are the people that work on Thursday. That has to be greater than or equal to 15. That's 6A. We have Friday, which we know shifts 2, 3, 4, 5, and 6 work on Friday, and the staffing requirement for Friday is 15. Label that 7A. And lastly, we have Saturday's staffing requirement, which we know shifts 3 through 7 work on Saturday, and we have a 15 person staffing requirement for Saturday there. And so when you think about this, we continue, so we have our staffing requirement constraints, which ends up being 7 constraints, 1 for each day of the week. We continue reading on and make sure that we've covered everything. We have these costs already incorporated. And so a logical instinct that people want to do is say, I'm done. But really we need to make sure that we're never staffing a negative amount of people. So the last thing that we have here is we have non-negativity. And so here we have x1, 2, 3, 4, 5, 6, and 7 are all greater than or equal to 0, which makes our 9th constraint here. And so if you think, okay, we have 7 days of the week, but what if we had a different staffing requirement for every day of the month because of seasonality or other sales that are going on? We would have a bunch of constraints here, more than just 7. So it's useful to learn how to concisely represent this using the sets and notation that we've previously defined. And so this takes a little bit of time to get adapted to the notation, but we're going to work through it here and consolidate these things into, when you see sums, we're going to consolidate it into summations. And then we see constraints that have similar structure, we're going to consolidate them together based off of those structures there. So if we see sums here, we're going to consolidate, and we're going to consolidate all of these constraints here. And so here, model format 2, what we want to do is we want to take this first constraint here, and we want to represent it more concisely. So I'm just going to write it out first. So we've summed over shifts, which we index by j. So here I'm going to say j equals 1 to n because we have n different shifts. And we see a multiplication here of a cost, which we have as Cj, multiplied by a decision variable, which is xj. And so here I'm going to call that 1b. Because 1a and 1b are equivalent, this is just a more concise way to represent the model. Then we have our constraints. And so what we're going to do is we see that there's a staffing requirement constraint for each day of the week. So we're going to represent this and consolidate it together. And we're going to do that. We're going to say, well, we have a constraint here for each day of the week. We're using I to index the days of the week. And we say all of the days of the week are in my set of days. We see all of these constraints do have a summation on the left-hand side. They have a less than or equal to constraint and a parameter or a value on the right-hand side. So here we're summing over something here. And so we're summing over shifts, but shifts that work on a particular day. So let me write this out first, and then we'll discuss. So we're summing over shifts, which is j, and shifts that are in, so that symbol is read as in, and in a particular set, which is d sub I. So to break this down, I'm going to have one constraint for each day of the week. Let's take the first day of the week. We say I is equal to the first element of days, which is Sunday. Okay, we say we're summing over j, so this is changing, but I is staying the same for this Sunday constraint, so we have d Sunday. So we're summing over all values j in d Sunday. And we're going to sum here just the xj's. And we want to make sure that they are greater than or equal to our staffing requirement, which is r sub I, which is specific to the day. So what I would recommend is break this down. So the j is an iterator here. So j is summing over all values here. So start with the I. So you would write this constraint for each value I can take on. So you would say I is equal to Sunday. So plug in that I for Sunday here and Sunday here, and then expand your summation. So you would have all values here of, let's see if I can get it to show it the same thing. So we would have all values j here that take on values in D Sunday up here. So j would take on 1, j would take on 4, then 5, 6, and 7 with a summation or an addition sign between it, which is exactly what we have for this constraint here. That continues. I would then iterate to Monday, so this would change to R Monday, D Monday, and j would take on all the values in D Monday, which is 1, 2, 5, 6, 7 there. And so this is just a much more concise way to represent the model. And so if we think here, this is consolidating down a bunch of constraints of 2 through 8. Lastly, I'm going to say non-negativity, and this is for j equals 1 to n, and this is 9b. Lastly, to represent our model, we would have a description. And so here I'm going to say in objective 1, so I don't need to have A and B, they're equivalent representations of each other. So we seek to staff the post office at minimum cost. And then really 2 through 8 have very similar structure. So I'm going to combine them. In constraints 2 through 8, we ensure the minimum staffing requirements are met for Sunday to Saturday, respectively. Lastly, we have non-negativity. So in constraint 9, we restrict the decision variables to be non-negative. And so that would conclude our scheduling model here. Thank you.